Hi, my name is Michael Hernandez, and I will be doing one of our homework two problems. And uh, this is an op-amp circuit, and this is from the textbook as well. And I will be showing and demonstrating how I complete the circuit. All right. So first of all, we're going to read the question. So it says VO in the circuit of the figure to VS. So we have to relate VO to VS and specify the linear range of VS. So it'll be a low negative and a high positive. And we assume that VO is equal to 0. Okay, so you can write down that VO is equal to 0. So that pretty much indicates that uh, if we have a voltage here, VP to VN to this negative terminal, we have a other voltage here, VN constraints to this negative right there. Um, the VN is across the VO, so VP is equal to 0. It's when you do VN, do VP, and then you do negative VO, which touches this negative terminal. It is already equals 0. And you could just move this VO to the other side. All right, and with the same idea, you can go to VN. So this would also be equal to VN, and then um, we can also say that this circuit is a summing op amp circuit, and the summing point is right here. So we can use all these voltages and resistors to sum them in a singular one and be able to solve this efficiently. All right. And so we have to specify a linear range. So we can use this VCC that is given, and we can say that the highest voltage and the lowest voltage is all in VO, in between VO. So it'll be negative 16 volts. There's the VO, and then 16 volts, right? So we have a VO we can relate. And pretty much the idea is get a equation that involves both VO and VS. And when we have that, we can move VO to the other side, simplify, and have the VO to plug it into this equation or this linear range and be able to solve for VS because we're gonna have VS. And so the first step that I will do is make a node voltage method. And we can see that we have a node right here, all these terminals. And we can say that is also a voltage source, is VS. And then right here, another voltage source is VO. And I made these as voltage sources just for better clarification. And this node, all these nodes, they're all connected together. So they're all connected to ground. All right. And so um, we can also say that there are currents here going on the bottom right here on all these right here and right here. And I mean, we don't know what the current is, but we have the voltage and the resistance. So, based on Ohm's law, we say that V is equal to R, and we could just do V over R to find our currents. So that's what we're gonna do. And so when we perform this circuit, uh, we're gonna use VP for this. So we can do VP, start right here. And because I said that all the grounds are connected to each other, we could travel right here and go to this VS. VS is with a negative terminal, so it's going to look like VP negative VS, and it touches this 2K ohm resistor. Is all just over 2K ohms. I'll put this Ohm's law right here so you can see it. All right. And so that's one of the currents that we did. And we're gonna have to perform this for this one, this one, and that one, because it's all connected to the terminal that we made from this node. And so with that, I will also do, we do a plus sign, and we do VP touches the negative terminal, this 3 volts, negative 3V over 4K ohms, and then we can do another VP minus 4 volts, 8K ohms, and then we do the other side, so then we do VP, and it touches this negative terminal of VO. So we do minus VO over 8K ohms, and it's all summed up to 0. Okay, so from here we know that VP is equal to 0 right here. That's we figured. And so we could just zero everything out. So it's going to look like this. VS over 2K ohms plus negative 3 volts over 4K ohms plus negative 4 8K ohms plus negative VO over 8K ohms, and it's equal to 0. All right, so we have this. And like I said, we need something to plug this in this VO. So we can move this VO to the other side. So we just do plus VO over 8K ohms. And it's just going to look like negative VS over 2K ohms plus negative volt 3, 4 ohms. And then because we move it, it's going to be VO over 8K ohms. All right. The most simple thing here, you could use a calculator to simplify this. I personally have a T-Inspire, the CX CAS, and you could just plug this into your calculator and it could solve it. But if you don't have a calculator, you could just solve this with algebra. So looking at this, our highest number is this 8, and I don't like working with fractions, so we could just multiply everything by 8K ohms. And it'll get rid of this and the units as well. And it would just turn into negative 4 VS because 8 divided by 2 is 4. And then 8 divided by 4 is 2. So we just multiply 2 by here. Negative 6. And then a 4. And everything's equal to VO. Then we could just sum this, be negative 4 VS minus 10, which is equal to VO. Plug this back into this equation right here. And so it'll be negative 16 volts less than negative 4 VS minus 10. And we'll do 16 volts right here. And then we can just add a 10 to both sides. That's what I'm going to do. Negative 6 volts, 4 VS, then 26 volts. Then we can just divide a negative 4 both sides. As well, we change the sign of these. So it's going to be positive, will be 1.5 volts. This VS, so this becomes a negative, be negative 6.5 volts. And this should be our final answer. Okay, thank you very much.